Hello guys, welcome to MoBileMaThS with Gamtry. Today I want us to look at geometric sequences 3, where we look at infinite geometric sequences. Okay, so when we talk of infinite geometric series, these are series that has no end or that do not end. Although an infinite geometry series never ends, we can say it is possible to calculate a value for certain infinite series, and we have a type that we can calculate for this one. This is normally the converging series. So we have got two types of series, infinite series. We have got converging infinite series and we have got diverging infinite series. Okay, so if a series keeps on growing infinitely bigger or smaller, it is not possible to calculate a value for it, and we call that type of series diverging. So for diverging, I can have an example of 2 plus 4 I can have 2 plus 4 plus 8 plus 16 plus 32 plus ... As you can see, we started with a small number and we are going, we have bigger number and bigger number as we go. So this one is growing big, and we can also have the one that is becoming smaller and smaller. So we can have an example of 2 minus 4 plus 8 minus 16 plus 32 minus, and so on. So for this type of series, it is becoming smaller and smaller. So for this one, the diverging infinite geometric sequences, we cannot calculate their value. It is difficult for us to calculate their values. Okay, then we have what we call, converging. We have what we call converging series. For converging series now, it is possible for us to calculate now the sum, or to calculate their value. We can easily calculate their value because they'll be converging towards or getting closer to a number that is 0. An example, I can have an example of a series of 1 over 3 plus 1 over 9 plus 1 over 27 plus 1 over 81 plus 1 over 243 plus so on. So if you see from this example, I started off with 1 over 3, which is a bigger number. This is 0.3333. Then we go on. This one is now it's now smaller. Even if you divide 1 over 243, you get a number that is 0.0 something. The number or the value is going closer to 0. Okay, so this is converging. So this type of series, we can find or calculate their value at the end of the day. So for converging series, we take note of our R as our R common ratio as a value that is between -1, R less than 1. Okay, so that's what we do when we are looking at converging infinite series. Okay, so we have a formula that we use when we are looking at these sequences and series. We have got sum to infinity is equal to a over 1 minus r. So we are saying in order to determine the sum to infinity of a geometric sequence, we use this formula. And our A is our first term, T1, and our R there is our common ratio, which I said should be between 1 minus 1 and 1. Okay. Then our S and this sign there, this is a sign of infinity or infinite. Okay. So this is the formula that we use. Okay. Now, maybe to explain it better, let's have an example of how we do this. So for this one, this is my T1, T2, T3. Okay. So this T1 is my A. Now what I can do is to find my R. R, we know our R is T2 over T1. So we can say R is our R is 5 over 100 divided by 5 over 10. So this becomes 5 over 100 times 10 over 5. Okay. And I can get 10 there, 10, 1, 1. So I can get for this one, my R is, so my R in this case is equal to, my R is equal to 1 over 10. Okay. Now I've got my R, and you can see my R is within the range of minus 1, R less than 1. Okay, because it's 1 over 10 there. It's within that range. Now, sum to infinite becomes A over 1 minus R. Let's substitute. Our A, we said it's 5 over 10, and our R is 1 over 10. Okay, so it's now a matter of dividing there. So we can simply divide, and you get your sum to infinite as 5 over 9. If you don't know how to divide this, you can follow our indices video. Okay, let's have another example. Okay, so in this example, I've got it's asking us to convert 4.81 to a common fraction. So 4.81, what it means here, 1 dot dot, it means it's recurring. So it's like we have got 4.8181818181. That's what it means. Okay, so if you want to find the to convert it to a common fraction, what we do for this question is this. We can rewrite this. Since we know it's 4.81, I can have it as 4 plus 81 over 100 plus 81 over 10,000. I'm adding 2 zeros, 81 over this other number there. So that's how I can rewrite this. Okay, so this is the same as 10 to the power of 6, 10 to the power of 4, 10 to the power of 2. Okay, like that. So having that, this becomes sort of a series for me. Okay, and if I look at this series, my 4 is not part of a series there. The series is starting at, my series is starting at this point going this side. Okay, so I can write my series as 81 over 100 plus 81 over 10,000 plus 81 over 100. Okay, this one plus dot dot dot. This becomes the series where I can have this one as my T1, T2, T3, and this one is also my first term A. Okay, so I can find the common ratio of this term, but I should remember the 4 and not forget that 4 in my head. That 4 plus something something. Okay, now having that, I can now say common ratio. My common ratio R is now equal to T2 over T1. So this is becoming 81 over this divided by 81 over 100. Okay, so if we have that, I can have my common ratio R is 1 over 100. Okay, so this is the common ratio there. And having that as the common ratio, I can now come, sorry, I think I forgot a number there. Okay, yes, a 0 there, such that if I divide this one and this one will cancel off, this one will cancel off with this. That's why I get my 1 over 100 there. Okay, fine. Now I can now go to my formula. Sum to infinity is equals to A over 1 minus R. Let's substitute. Our A, we are saying our A is 81 over 100 over 1 minus our R is 1 over 100. Okay, so if you divide this, you should get your sum to infinity as 9 over 11. Okay, so this is the sum of those terms that were recurring. But now if we go back to our 4.81 these dots there, this becomes 4 plus 9 over 11. Okay, now having that, we can proper fraction and have it as 53 over 11. So this is the common fraction that we can write for 4.8 there. Okay, so this is the final answer. Let's have another example. Okay, so this one is asking us to show that 0.99 is equal to 1. Okay, so 0.99, we can do the same. The dot there is meaning that it's 990.999999. Okay, so we can have it as 0.9 is equal to 9 over 10 plus 9 over 100 plus 9 over 1000. Okay, and so on, like this, plus dot. Okay, so for the first term, there is our first term T1 is this one, which is our A. This is our T2. This is our T3. Okay, we can find our common ratio. Our R is equal to T2 over T1, which is equals to 9 over 100 divided by 9 over 10. And when we have this, it is simply the same as R is equals to 9 over 100 times 10 over 9. 10 over 9. And these will cancel off. These will cancel off. So we'll have 1 over 10. This is our R. Okay. Now we have got our R and our A. We can do the sum to infinity. Sum to infinity of that is equals to A over 1 minus R. And if we have that, we can substitute and we have our A 9 over 10 over 1 minus 1 over 10. Okay, and if we simplify that, let's simplify together, we'll get 9 over 10 divided by 1 minus 1 over 10. Okay, I want to simplify the bracket side first. So I'll have 9 over 10 divided by 1 minus 1 over 10. It's as good as 10 over 10 minus 1 over 10. Okay, so I can have it as 9 over 10 divided by 9 over 10. Okay, and we can now say 9 over 10 times 10 over 9. And if we do that, we will get this one divides there, this one divides there, and we'll get our answer is 1. So sum to infinity of that one is equals to 1. So we have proved that, or shown that this number there is equal to 1. Okay, so guys, please Please remember to subscribe on our channel and share our videos with your colleagues. Bye bye for now.